Hello, so in Chapter 6, we're going to look at inverse functions. And this includes exponential, logarithmic, and inverse trigonometric functions. In addition, we'll also look at hyperbolic functions as well. So these are all going to be different types of what we're going to call transcendental functions. But before we get into any of these, we're going to spend some time just thinking about what inverse functions are and doing some calculus on inverse functions. So before we get to that, we're going to have to first define what one-to-one functions are. So if we remember, a function is called a one-to-one function if it never takes on the same value twice, or as we're saying it here, f of x1 and f of x2 are different whenever x1 and x2 are different. We can see in this diagram here that the way that we're defining the function f, for instance, sends the value 4 to 10, the value 3 to 7, 2 is sent to 4, and 1 is sent to 2. So since each of these input values has a unique or a different output value, the way f is defined here is 1 to 1. On the other hand, if I look at the way we've defined the function g below here, it's sending the values 3 and 2 to the output of 4. So the output value of 4 has two values, 3 and 2, that both get sent to 4. So here we see that g of 3 and g of 2 both equal to 4, but 3 and 2 are different. So this is an example where g is not one-to-one. Okay. So that's one way to think about it, is one-to-one functions have unique output values. Each output value comes from a different input value. Let's look at these two examples here. If we're looking at the function f of x equals x cubed, I can clearly see from its graph here that each different output value is different. In other words, I can check that any horizontal line that I draw in the graph only crosses it once. So this certainly passes the horizontal line test. And that's a good way to tell if a function is one-to-one graphically. So yeah, is f of x equals x cubed one-to-one? And the answer is yes. We can see that for any different x1 and x2 value, we see that x1 cubed would be different than x2 cubed. Okay. What about g of x equals x squared? Now this one, I notice, does not pass the horizontal line test. So what can we say about this one? If it does not pass the horizontal line test, what that means is that essentially there's a horizontal line that passes through the graph at two separate points. For instance, this horizontal line that I draw up here passes through the graph at two separate points. And so that corresponds to two different x values, say x1 and x2, that have the same output value. So we see that here f of x1 and f of x2 would be the same. And in fact, we can show this very easily with a counterexample, that g of x is in fact not one-to-one. Right? We can take, for instance, g of 2 and g of negative 2. Well, we know when we square positive 2, we get 4. But when we square negative 2, we also get 4. So we see that g of 2 and g of negative 2 are equal, but 2 and negative 2, of course, are